Hi all, welcome to the Selenium test meet. This is not a session recorded with anymeeting.com which we had today. The recording just did not work, so I have to recapture everything again. So let's see what we are going to see today, and yeah, let's begin with the test then. So we will see today how soft assertion works in test. That means to say that how we can continue with the test execution even if one or few of the assertion fails. Then we will see how CSV files can be used to externalize the test data and to test application against a large number of data sets, and then we will see how Selenium Grid can be used to scale test, to execute test against different environment. Yeah, so let's begin with it. So I have all code set up ready, and I'm going to explain it to you guys first how soft assertion works. So if you see, if we use multiple assert statements in a method, if any of the assert statement fails, then test execution is not going to continue. One of its example is in this hard assertion method. Herein first assertion succeeds. If you see second and third assertions, these element locators are not actually available on the page, because of which these two fails, and then the third assertion should succeed. But how it works is, if any of the assertion fails, the execution is not going to continue. So as soon as control comes to executing driver.findElements by name, wrong last name, it encounters an error and this is going to fail. So let's execute it and see. Yep, so here comes the browser or application demo tour. Yeah, so it's over. It's a very small test. So what's happening here is we just launch the application URL and then we check the presence of certain elements. Okay, so let's see how it is indicated in our test report. So yeah, as you all know that after having executed the test, just refresh it here, and then you have index.html file available in the test output. So that comes here and it should show us the test result. So this is a method, hard assertion, which we executed just now, and it has failed, and the message which is printed here is last name field is missing. So this is a message which we had passed here. Yep, last name field is missing. So if this condition fails, the message is printed. But the problem with this type of mechanism is test is not going to check for the assertions which appear after this assertion. So if we want to do that also, this approach is going to fail. This is where soft assertion comes into the picture, wherein test execution continues even if some of the assertions fail. So let me show you another method here. So this is the soft assertion. The mechanism is same. We are again launching the application URL and checking the certain number of fields, out of which second and third statements are going to fail, and fourth statement is going to work, as well as the first statement. Let us see how it differs from the hard assertion which we have here. So in case of soft assertion, what we are doing is we are not using assert.assert true. We are using here custom verification class. So we created an object of custom verification. We'll have a look at its implementation also, but let's first see how it differs from the hard assertion. So we have custom verification object here, and then we have custom verification. We have certain methods being invoked over the custom verification object. We are using verify true here. Rest of the thing remains same, and then at last we are checking for the verification error. Now if I execute this, we will see that there will be two error messages printed. One, last name field is missing, another, phone number field is missing, because these two checks are not correct. I have induced these failures, and after that it would succeed because the email address, that's the username field, that's right. Let me execute it. Yep, so it launched the application and it carried out the test. Now let us see the report. Let me refresh it. Yeah, so if you see here, let me maximize it. Yeah, if you see here, we have the soft assertion method which has failed, and it says that there are assertion errors, but we cannot really figure out from here what went wrong. So let us go to the reporter output which is available in the TestNG report and see what has happened. Yeah, so here we have two messages being printed. Last name method is missing and phone number field is missing. So if you compare it with the hard assertion, we had only one message being printed there, which was the last name field is missing. So this is evident from here that even though there was an assertion failure, or a verification failure, the execution continued and execution has reported all the failures it had encountered. So this is the advantage of using soft assertion over hard assertion. Now let us see how it is implemented. So in case of hard assertion, it was pretty straightforward. We were calling the assert true methods on the assert API of JUnit, I suppose. Here, now here we have got the custom verification object. So let us see how custom verification object is implemented. Let us go to the custom verification class. This is the custom verification class. We have one instance variable here, which is a string buffer. It is named as verification error. Advantage of using a string buffer over a string is that since a string is immutable, every time we concatenate something, it creates a new string object. But in case of a string buffer, we can keep appending these string objects. So there's a method here called append, which we can use. We'll see that later. Okay, so we are initializing this in the constructor of the custom verification class, and then we have couple of methods which are very similar to the methods available in the assert class. For example, we have verify true, verify false, and verify equals, and few of the methods are even overloaded. So let us see the method which is being used in the WebDriver test. So we are using here verify true. So let us see how it is implemented. Yeah, so verify true, it takes the message argument which you are passing there while calling the method and the boolean. Now within this method, what we have done is we have wrapped the assertion within try catch. So if the assertion fails, the execution is not going to get aborted. Now how we are doing here, how we are handling or capturing the message here is we have assertion being kept in the try block. If there is any exception, then control comes to the catch block, and the catch block, what we are doing is in the verification error object, we are appending the exception message which might be thrown in case assertion went wrong, and at last we print the log message. Okay, so if you see here, if I come back to the test again, so verify true, what I have here is I have this message being passed to the method, and then this condition which is to be checked, which could be either false or true. Now if I see the implementation, the condition could pass or fail here. In case the condition fails, control comes here and control appends the exception message to the verification error object, and then prints the message in the reporter using the reporter.log API of TestNG. This is how we are able to see the failure messages here in the reporter output. Okay, so this is why we have last name field is missing and phone number field is missing, messages being printed, because in the test these are two conditions which are not satisfied. These two conditions fail. So test locks these messages and continues with the execution till it reaches the last statement in the test. Now let us see what more is there in custom verification class. So we have couple more methods similar to verify true, and then we have two different methods, clear verification error and check for verification errors. So once we are done with the test, what we have in our test method is we are invoking check for verification error method. So let us see what it does. Check for verification error identifies that if there was any verification failure while conducting the verify true or other methods. How it does that is it sees whether the verification errors string buffer which we have here, the verification errors string buffer which we created earlier, whether it is empty or not. So what we are doing here is we are taking the string representation of verification errors, and then we have an if condition wherein we compare that verification error string should be empty, that is, this should be equal to just quotation. So if it is not so, in that case we call the fail method of the Selenium test space, and what it does is it eventually marks the method as failed. And we are also clearing the verification error. How we clear the verification errors? We again instantiate the verification error object. Clearing the verification errors is necessary, because if we do not do that, then our further tests are not going to run, because verification error for the test will run, but there would always be error here because the verification error object is always going to contain some message. So it's necessary to clear the verification error after we are done with the test, and we want to check whether the verification errors are there or not. Okay, so let me summarize it once again. What we have done here, we are creating the instance of custom verification object, and then we are calling these custom methods here. Just one method, verify true, which tries to find whether assertion is true or not. If it is not true, then it captures the exception message and appends it to the verification error string buffer and locks the message in the reporter log, which appears in the TestNG report. At last in the test, we call the check for verification errors, and this is going to check whether there was any verification error or not. But while doing so, it would also clear the verification error so that we can use the verification error, the custom verification class for further checks. Okay. Yeah, so that was about the soft assertion. Next we are going to see the how to use the CSV file to capture the test data. Okay, let us see how we had seen the usage of data provider in TestNG in our last meeting. Okay, so we had seen one method in the last meeting, new registration, wherein we had created a data provider. We had named it rich data, which is available in the registration data class. The class is here, and yeah, here is the method. Now we know from our previous session that the data provider returns two-dimensional object array. So what we had done here was we had created one registration data object. We had filled it here with all sets of test data which is needed for registration for demo to our site, and then we were returning this one registration data object. How so? By instantiating the registration data two-dimensional object array with the registration data object which we are creating here. As simple as that. But there were certain problems with this approach. First problem is we are hard coding test data here. Second problem is it is static in nature, and by static I mean that test is being carried out for only just one set of registration data object here. What if we want to do it for say 10 set of registration data objects here? So we cannot really hard code all values here and keep changing the number of keep changing the data elements in the registration data object. This is for which I have created a CSV data file using which we are going to carry out the test now. So let us see the format of CSV data file first. So the data file is available since it's a Maven project, the file is going to be within so I have kept it in main resources. We could keep it in SRC test resources also. So this is the data file. So let us see what all data we have here. So we have first name, last name, phone number, username, country, email address, password, and confirm password. Now this data file may grow in size over a period of time, so we do not really know, we may not really know in advance how many rows could be there. But one thing for sure, we are going to know that this data file has certain format, and the format is going to be, there are going to be 8 values separated by comma, and we know that what would be the first value, second value, third value. Well, we may not know what the value would be, but we know that what it represents. For example, in first, second, and third row, the third value or the third column is always going to be the phone number. So this is the format which anyone who is going to use the CSV file would have to follow. Okay, now coming back to the test. Okay, so this is our new test. So this test uses the new data provider, which is rich CSV data. The data provider class is same, rest of the test is same, there is no difference. The difference is in how data provider is implemented now. So let us go to the data provider and have a look at that. Yep, so where is rich CSV data, and here is our rich CSV data. Okay, the same mechanism here, TestNG data provider, it is going to return two-dimensional object array. Now how we are doing this is, so what we are doing here is we are using a CSV reader to read the CSV file. I am using here Open CSV reader. We had seen in our last session that in the POM, if we want to use more jars, we can add a dependency there. So I have added a dependency here. Let me go to the POM. Okay, let's see pom.xml. Yeah, so we had Selenium dependency and TestNG dependency in the previous session. I have added one more dependency, which is Open CSV here. That's all, there's no other change. Okay, now this Open CSV lets us read values from the CSV file. Now we had seen in our last session that how we can read how we can refer to a file if we are using Maven. So what we have here is we need to create a CSV reader object, and this is the constructor of the CSV reader. It takes argument as file reader. Now how do we get to the path of the file? We first get to the class object of the class, which is registration data here. Then we use get resource method, and then we pass the name of the file. How we do that? In quotation / name of the file, and then .get path. So this will get us the path of the file. So this is a way by which we really do not have to hard code the path of the file. Now coming back to how data is constructed. Okay, so here the next statement is something wherein we are going to get list of all string array. Okay, how do we do that? Once we get the CSV reader object, we are calling a method called read all. This method is going to get us a list of all string array. Now what are these string array? Well, these string arrays are nothing but each line in your CSV file. So one line is one string array, second line is second string array, third line is third string array. Okay, coming back to the data file, next we have the declaration of two-dimensional object array, which would eventually be returned from your method here. So this is two-dimensional object array. Now we have to when we are declaring this two-dimensional object array, we have to declare its dimension. So what I have done here is its dimension is, the rows at least are not constant here. So what I have done here is, using the data list object, I can find out what is the size of data list object, and that is going to be the number of row which would be contained in my two-dimensional object array. Okay, yeah, and the column is 1 here because this two-dimensional object array is going to contain one element for each of the row, and this one element is going to be registration data object. So for example, if I refer to it as say first row as 0 0, it would have one registration data object, second row 1 0, it would have another registration data object, third row as 2 0, it would have another registration data object. Okay, after this what I have is, I have created another list, and this list is going to contain the registration data object. We will see later that this list is used to populate the data object file. Okay, now let us see how we are creating all the registration data object. So we have our data list here, which is a list of all string array. So I'm using a for each loop here. For a string, I have named it a string array, iterating through the data list here. Now I have to create registration data object, new registration data object for each set of rows. So within a loop I am creating new registration data object, and I know here that you know what each element in the row represents. For example, the first element is going to be first name, second element is going to be last name, so on till last element, which is going to be confirmed password. So what I have done here is, how I'm filling this registration data is, I have the set first name method which we had seen in the previous sessions, and then I'm taking the 0th argument, because in array indexing begins with 0, so 0th argument, this will be my first name, first argument, this is going to be my last name, third argument, which is going to be my phone number, till I reach the confirmed password. Okay, once I have set all these values in the registration data, what I'm doing here is I'm adding this to this registration list. Yep. So this how I create all the registration data objects and fill my registration list with all of these registration data objects. Now once I'm done with this, once I have this list filled, what I have to do is I have to fill all these values in my two-dimensional object array. So what I have done here is simple loop here. This is a for loop which is being used to iterate through two-dimensional object array. So we have outer loop and an inner loop. Outer loop is going to iterate through all the rows, so it goes till the length of the array, and the inner loop is going to iterate through all the columns, so it goes till the column count. And then here where assignment happens, so we have data, which is the name of the two-dimensional object array ij, and then we have the rich list, which is a list. How do we get the element from the list? Using the get method, get the value, which value? The ith value, that's all. And here we get our two-dimensional object array populated. Now after this I close the CSV reader file and a CSV reader object and return the data. Okay, now come back to the test. So test is same, there is no difference in the implementation of test than what we have in the first method we had seen in the previous sessions. Okay, then we know that at this point we have 3 set of values in the registration data files. So if I execute this test, we will see that it is going to get executed 3 times for 3 data sets. One more thing to notice. In the data set here, the first data set and second data set are correct. The third data set is not correct because the country value which is being used here is not actually a valid country value. So test will fail for this data set. So let me execute it and show. Sorry. So yeah, first browser comes here, and yeah, it clicked on submit. Well, it's waiting. I hope it comes up soon. And this test is going to succeed, provided that next screen appears quickly. Yep, so this test is over. Now the test will happen for second data set. Let me bring up the console, that will make it easy to understand. Yep, so this is second data set. The country was Peru here. The submit has happened and application is refreshing now. This is again a valid data set, so test is going to succeed here as well. Yep, so registration is over. Now comes the execution with third data set, which is a wrong data set. The country is wrong there, so test would fail here. Yep. Now let us analyze the test report. Let me refresh it. Okay, so we see here that it displays as 3 methods because the same method was executed for 3 data sets, and it says 1 has failed and 2 have passed. So in case of failed method, it indicates the data set here, which is the registration data object. We cannot really figure out from here what data was passed for registration data. We'll see that later, how we can identify the data set. And then these are the pass methods, which is the same method as new registration using CSV file. Yep, they are listed here, and here the registration data object is different. This is the string representation of the registration data. This comes from TestNG itself. Now the report is good, but we would also like to find out as to what has gone wrong, what was wrong with this registration data object. So let us see what has gone wrong. So let's try to remember, this is registration data at the rate of 5F42. Let's see here. Yeah, this is the 54F2. So here we have all the data values being printed which were used in the test, for example first name, last name and other things, and from here we can see the country is wrong. So well, this was just an example, but in the real testing, when an automated test fails, we would know that we can see through the test data, and then we can manually debug the application and find out what is really going wrong. Okay, now let's see how these values are being printed in the reporter file, because we have not printed them here, at least in the registration data class. Okay, so how I am getting them printed is we have this register new user method. So when registration data is passed here, I am logging all of these using the reporter.log. So we saw that this is an API in TestNG, and this is how the test data values are getting printed in the reporter reporter output file along with the method name. That's all. Okay, so we completed 2 topics, the soft assertion and the using CSV file. Okay, then let us see the Selenium Grid now. In fact, I have been using Selenium Grid in the execution so far. If you have a look at cell test case class, which is our base class, what I have done here is I have commented the Firefox part here, and then I'm using something called desired capabilities. Okay, but before that, let's understand the advantage of using Selenium Grid, or what the grid is all about. So far we had seen that we were running tests locally. Even now we are running tests locally, but we may have test requirements wherein we would have to run tests on different browser and operating system combinations. For example, Firefox 10 on Windows, and some version of Safari on Mac, and some version of Chrome on Linux. In that case, it's not going to be possible to run all the tests on one system, and this is where Grid comes into the scene. Grid helps us in scaling our test, in distributing tests on different environments. And here Grid is going to have one hub which is going to behave like a monitor, and there are going to be multiple nodes. These nodes register themselves to hub, stating that what capabilities these nodes have in terms of executing the test. So when when a request comes to hub that okay, a test is to be executed say on Firefox, on Linux, in that case hub goes and polls all the nodes and finds out which node is going to fulfill this requirement and execute the test on that node. So in a gist, hub is a monitor here which is going to overlook the execution. Nodes are, we can call them slaves, which register themselves to the hub, letting hub know that what capability the node has on which test could be executed. So this is a theoretical explanation, but how this fits in our test. Okay, so what we have done here is we have created a desired capability object using which we can define certain properties for the node. Here I am using the Firefox as desired capability, and then I have set the platform here. I am running on Ubuntu, so I have set platform as Linux here. Okay, so this is till the capability part of it, but how do we create the driver? How do we instantiate the driver? So far we were using the concrete implementation, say new Firefox driver or new Internet Explorer driver. Here we are going to use the remote web driver, and the remote web driver constructor takes two arguments here, the hub URL as well as the capability object which we created here. So well, I'm running test locally here. That's the only way for me to showcase here, but you would not have hub being started locally. You would have hub running on one machine and you would have multiple nodes. Let us see how they are registered. Let me go to my console. Okay, I'm already running hub and the nodes. So let me shut down the hub. So I have the jar file available on my system on my desktop. So how do I start hub? I started as java-jar, name of the jar, with the argument as hub. So I say -roll hub and just hit enter. So this is going to start the hub on the port 4444 by default. Now let us see how we start a node. So I'm going to shut down the node here to show you how we can start the node. Yeah, so this is how we start the node. The beginning of the syntax is java-jar, which is going to execute the Selenium server jar. Earlier we specified -roll hub because this was hub. Here we specify as -roll node because this is a node, and now we have to let node know where hub resides. So we write it as -hub and the URL of the hub. Remember, this is not going to be localhost in your case because you might be running hub on one system and nodes would be running on different operating systems. Okay, so yeah, let me start this. Yeah, so this starts here, and yeah, so how we were executing test is they are being executed in Firefox every time. So driver knows the hub knows where which node is capable of running the Firefox. In our case, it is going to be the local host where we are running hub as well as the node. Yeah, so that's about the grid 2. We have set up only with Firefox here. We can set up with IE and Chrome as well, and we can set them up with more properties and not just once. So let's see. Yep, that's about it. So yeah, it brings us to the end of the session. So let's meet guys in next session now.